Yeah, welcome to Advanced Data Modeling in Power BI. I'm Markus, and thanks for the nice introduction from Michael. So when it's about data modeling, I introduce myself. Hi, I am Markus, and I work with models. And when I do so, people start to think like I work with beautiful people. Sometimes I do work with beautiful people, but what I'm referring to is that I work with beautiful, hopefully beautiful data models. And that's the models I work on. So what you can see here, tables and connections and everything here. Since many years now, as Mikhail pointed out, I started early, 5 years old. Not sure if this is true. So Power BI Desktop, Analysis Services Tabular, it's the same. If you think about the data modeling, it's the same thing. It's like the same source code is maybe a different version depending on which kind of Azure analysis services or SQL Server analysis services you're using, the tabular one. It's the basic principles. So all the principles, when I say Power BI Desktop, it applies also to Analysis Services Tabular or the other way around. It's the very same thing. And what we have to keep in mind is those are optimized for a star schema. If you've not heard about the star schema, please do your homework, check this out. Basically, in a star schema, you have fact tables, and those fact tables don't show any connection, but they connect to the dimension tables. And dimension tables don't have any connection with each other, but only a one-to-many relationship to the fact table. And you can have more fact tables, and dimension tables can have connections to more than one fact table. That's what we call conformed dimension. But that's it. It's a very simple, so to say, modeling approach. And the Vertipex storage engine and also the DAX language are optimized for that. They're built with this in mind. So if you're not having a star schema, but for example, a normalized schema or a single table, you might get in troubles because your DAX will maybe not work, will be hard to write, or even return the wrong numbers. And you can like this fact or not. This is how the product was built to. And it's also optimized for one-to-many relationships. So for example, one customer as the customer table or the customer ID is filtering our sales table. There's no bidirectional filter. There's no many thing. This is not built for. We can build this, and we'll talk about that in this very 60 minutes. But this is not, it's not optimized for. This is not what we should go for. We should find a solution to still have a one-to-many relationship. It's not always possible, but that's what we should work for. And it's also optimized for unidirectional. One filters going in just one direction, not bidirectional filters. And I think in some time of the history of Power BI Desktop, there was even the default bidirectional filters. And this was a really bad idea because people thought, if it's a default, it's good. No, it is not. It will make your model slow. So one of the reasons why your Power BI Desktop report is slow, even if you don't have so much data, is maybe you're having a lot of bidirectional filters. They make the model just slow because the product is not built for it. And on the other hand, it could be situations where you cannot add another table, again with a bidirectional filter, because you would end up then in circles. So then you have an ambiguous model. That means that there's like more than one possible path between two tables. So Power BI does not know which path to choose. And then Power BI will tell you, you cannot add another table, or you cannot add the bidirectional filter. And then you're struck because everything is built on those bidirectional filters, but this table is different, and this makes it hard to understand your DAX statements and also the reports. So that means you should avoid many-to-many relationships. You should avoid detached tables where there's no relationship. You should avoid this weird key value pair model. And that's exactly what we talk about. So the agenda for this talk is building many-to-many relationships, detached tables, and key value pair model. But just want to emphasize this. Don't use my talk and this recording and this talk today as an excuse to violate the best practices. Always go for the star schema, always go for one-to-many, always go for unidirectional filters, except for certain use cases where we have to reach out. And for those use cases, those exceptions are built. They're not built for the normal average model. So keep this in mind. So agenda is multi-fact models. Budgeting will be the use case here. Then many-to-many relationship, which is also part of this budget thing. Then we will talk about detached tables. So I have a table with no relationship at all. Why would they build this? This will be slower, and why should I do that? And the key value pair model. So that's what we're going to see in the next 50 minutes also. So multi-fact model. What's a multi-fact model? Multi-fact model means that I have more than one fact table in my model. This is also referred to as a universe. If you think about stars, and there's more stars, and those stars build then a universe. That's like the the terms we use here. Why would you have more than one fact table? Because usually you would build everything in one table. The reason is because you have different granularities. You have one table maybe on the date level and product level and customer level and so on, really granular, on a low granularity, very detailed. And then you have other information which you don't have on daily level, only on monthly level. Maybe you don't have a customer attached to this information, but you have a product related information, but it's like on product category level. So there's different granularities. And for this, you would have then several fact tables per granularity. So always you can add as much information to one fact table, but don't change the granularity. So get better soon, Daniel. Okay, I'm not really knowing what this is referring to. So next one, and they share at least one common dimension, because if they're not sharing anything, maybe you should not put this in one report. Maybe you could, because they have two separated reports that are totally independent, but most commonly you would expect, if I take, for example, select the year and both are time related, that both facts are filtered by the year. Or if I select a product, then or the product group, then both are selected by that. And my bet here is with the general availability of direct query mode over Power BI and analysis services, an awful thing, and there's not even an acronym currently, this will be much more common. So what that means is currently, if you have analysis services model or you have a Power BI dataset, and from Power BI you connect to analysis services or to the Power BI dataset, either you load everything, which is not a good idea usually, to reduplicate everything, or you are in live connection. That means that Power BI doesn't contain any data. Everything you're doing is sent over as a DAX statement, and then the result is then queried off down. The disadvantage with this is you cannot add other information. So maybe I want to connect with my data warehouse, centralized analysis services, a database, and I want, for example, add budget information, or I need a different grouping for my territories. This currently is not possible, but there's a preview for that. So you can turn this on currently. The preview is available since Power BI Desktop version December 2020. Currently, there's no ETR available. I'm not sure, but don't know anything when this is planned. Obviously, this is really hard to build. There's no other product on the market out that can do that, and already the preview was postponed. Ursprünglich, now I'm talking German. Originally, it was planned for October last year, and then they pushed it until December. So I'm not sure what's happening there, but with this is a very certain use case, like having your actual data and then taking just your budget. The budget is not part of the data warehouse yet, maybe, because you only want to try out and see if the budget makes sense or not before you hand it over to IT to make it part of the data warehouse. And then you would have things in different granularity. So this is a really important skill you should have to model things like that. So my bet is there will be lots of requests and misunderstandings and things to learn with this new availability. And everybody has to learn this because this is really new to the industry. So nobody has experience with that. So we have to learn how this will work, how we can performance tune this, what's best practices. There's no best practices because there's no practices except for the preview currently. So what I took here as a use case is the budgets. It's not a mixed or composite model, but just one simple Power BI file. And with the budget, we have exactly that. We have different granularities. The budget is on different granularities than the actual values. And I made it really, really simple here. So it's only the product. The current, the actual values are on product level, and the budget is only product group level, but they share the same date to make it just easy. We only concentrate on one dimension. And as far as I found out and researched and tried out, there's three possibilities. We can use 3DAS, which is a function in DAX. It's called 3DAS, not what I thought, triatas, like a Greek goddess. No, it's 3DAS. So we're treating a table as if there would be a filter from another table applied. Then we could have many-to-many relationships. So we are evaluating the best practices, or we could build a bridge table. That's what we take a look in the first demo here. So what do we have here? So this is an really easy example. Easy example means not very complicated data, not a complicated model. So we concentrate on on the important things. So we have a sales table. As soon as it appears, we see there's only 4 rows there. So for the first of the month and second and third, we have some sales here for 3 different products, different amounts. And then we have the product table. And there's a connection in between, as we will see soon in the model view, which are grouped, group 1, group 2 for the first 2. Now the other one is also opening up, and group 2 for the other one. And that's what we see as a result here. So if you look at the actual as a sales amount, that's the actual numbers here. So we have for October, group 1, October, everything is in October, and group 1 means this is A and B, 100, 110. So this is those 3. And this is 32, right? Not 30, 33. Oh my God, this is a long, have been a long day for me. 33,000. And then for group 2, as you see here, there's 120 and 30 is part of group 2. There's only one for those, for each of those. So only one for them. Only for 120, it's 15,000. That's the number we get here. And the sum of those two is 48,000. Easy. And then we have the budget here. And as you can see here, there's no relationship to the budget because I have this relationship here from the sales to the date and from the sales to the product. I made a relationship also from the date to the budget. One-to-many relationships, easy things. But there's no relationship between budget and product because there's the product group. I don't have a budget on product level. The granularity of the budget is different from the sales. I cannot really connect it with the product ID. If you're using older version of analysis services, you cannot. With the new one and Power BI, we can then have a many-to-many relationship, but first try another solution before we talk about it. And the backdraft with having no connection here, no filter, we see these effects that like some numbers appear several times and then the total doesn't really make sense to what we see in the details. The reason here is because this line filters the month on October and the product and group. But the product is not filtering the budget. Only the month of the date table, we don't see the date table in here, is also filtering the budget. So what I'm getting here, only the filter from the month is applied on the budget. The filter on the group, which is coming from the product table, is totally ignored. And we think about October 29. October 29, we have 2 lines in here. This is 20 plus 7. This is the 27,000. This is repeated because we have the month 2 times here. And the other effect is the 60,000 here. Everybody should know in Power BI, in DAX, the total is not the sum of those individual values, as we can see with our own eyes here, but the total is always a total because there's a different filter context. There's no filter applied on the month or on the group. If there's no filter applied, this means we get a total of everything. So this is the total of all the budget. 20 plus 7 plus 25 plus 8 is the 60,000. But this is nothing, this is not useful, right? So we're missing out the group 3 here, and the numbers don't sum up, and we get duplicate. So this is nothing we could show anybody. So what we can do here, first solution is reaching out to TreatS. So I made a measure called budget TreatS, and in this I just sum up the budget column of the budget table, a sum over this. So there's the column, there's the sum, and then I wrap this into calculate because calculate can help me to apply a filter, to change the filter, to change filter context. And TreatS does exactly this. So with TreatS, I have 2 parameters. One is please get me the list of available product groups. So that means I have in the product table, I have a product group, and this is filtered, right? You can see here there's like a filter applied either group 1 or 2. This filter is then applied onto the product group of the budget. And as we can see here, this looks better because now for group 1, we don't have a budget. Remember, the budget is only there for group 2 and 3, not for group 1. So this is right. Group 1 doesn't show anything here. This is the old one, the old budget. This is the new one, the TreatS. And for group 2, for October and November, we see the right values, 20, 25, and even the sum is correct, 45,000. The only thing is, group 3 is missing. Why is group 3 missing? Yeah, because this is not available in my product table. I don't have any products for group 3. Group 3 is a new thing in the budget, but not in the product table. So TreatS works as long as there's no difference in those product categories. So this could work for your solution. Does not work for this solution because I want to keep it one step more complex. If you don't want to use TreatS, there's a reason why not to use TreatS, because TreatS, there's no real filter connection there. So there's no relationship. And if there's no relationship and I filter without the relationship, this will potentially be slower. I build a model like where we had like a dimension table where we filtered with TreatS 1 million rows, no effect. So it was was performant, but there could be a potential performance issue. So maybe it's better having a relationship. What we can do here, I can grab the product group and just pull it over the product group here. So now I'm creating a relationship, and as I get a warning here, it finds out that this relationship, the relationship has a cardinality of many to many. It found out that like group 1 is not, so the group here, this is not distinct, and also the product group is not distinct here. We can also see duplicates in here. So it will not allow us to use one of those tables as on the one side. Obviously, both on the many sides. But it's only a warning. I can still press OK. It's just warning me. Are you sure what you're doing? Please read this article and learn about many-to-many and all the disadvantages. But I can say, yeah, okay, I'm aware of that. And I make this even an active relationship. And then I cannot, because I have to change the filter from the products to the budget. And then we can make this an active relationship. So now we have an active relationship, a many-to-many relationship, but still it's the product table is now filtering the budget table. So I do not need to use treatise. So if I'm going back to my report, now also the budget is exactly the same like the budget treatise, even if I don't have a treatise in here, and also the same appears here. So this is also not changed, and I get these numbers in here. This might be better because the total is the right one. I just don't see the group 3. So this is maybe a step better than the treatise, because with is it here also? What's here? The treatise? Yes, with the treatise we have only 45,000, but we have the full 60,000 here. So there's a slight difference also here. Not only performance, but also the result. But maybe this is not satisfying. We want to see the group 3 here. And that's what you usually do if you take a class in database modeling. Then you will hear about normalizing and so on and so forth. And there's also this challenge having many-to-many relationship. And usually in relational databases, we solve this by having a bridge table in between. So now I have a connection between product and budget. And now we get the solution I was striving for. So now we have for October 3 entries, group 1, 2, 3, and also for group 2 and 3 for November. And I also see the 25 and the 8,000 here. And this 60,000 is the perfect sum of those numbers here. So now obviously I have found a way to show all the groups from the product and also the groups from the budget, and apply this to my report. So how did I build this? This was done with a bridge table, so-called bridge table. So instead of having a many-to-many relationship, I still have this many-to-many relationship logically, but physically I have a table in between. And this table is a one-to-many relationship in both directions. So if I filter the product group, it will then filter my budget. It will also filter my product. And this is what I used in my report. So I used the product group column from the product group table in my report. So the question is, how can you build such a bridge table? This is not very hard. You can do this like in SQL by getting a union of those two tables and find then the distinct product group. You can build this in Power Query. Here, I just limited myself to DAX. So that means if we take a look on this product group table, which I hit, then we can see here, I get this product group and there's 1, 2, 3. The order doesn't really matter. And I built this by referring first to the budget product group and to the product group, and I get the distinct values of both of them. So I get a distinct list of the one product group column and another distinct list of the other product group column from the product table, and then I union them, both of them. So this is putting them just underneath each other. And as there can be product groups in one table and also the other table, I have to apply another distinct here. So that's the reason why we see distinct here and here. And this distinct here is necessary. I could also use values, but what I need is like to transform the column in a list of columns, in a table of columns. That's why I use distinct here. You could also use values. Not so much of big difference here, but it's important that also in the end you have a distinct that you only reduce to distinct values, because this one has to be on the one side of the relationship, and this is only possible if it has a distinct list of values there. Think about treatise, like you have active relationships. Those are the better choice, because that means they are persisted in the model. They take up a little bit space, those active relationship, but this is like a filter in a relational database. So the relationship is persisted as a list of key combinations. So Power BI and the word repeating engine has a nice time to finding out about the different connections. So when I have one key there, what are the matching keys in the other table? So the virtual relationship might look very attractive because then your model is really, really easy. You don't have any relationships in the model. So this means an easy model, no relationships in there, just tables. But the backdraft is there might be a performance penalty you have. And that leads me to detached tables. This is similar now because detached tables means there is no relationship. Why would I build a model without having relationships in there? Maybe because I cannot. So detached table means that there's table, at least one table. This would be the detached table. It could also be several detached tables which have no physical relationship in the model view to other tables. So from a performance perspective, of course, this is only feasible for smaller tables, but as I pointed out, test this. We had have one customer where we have like used 3 days with a table with 1 million rows, and it works fine. Why we would use this is because in the relationship views, if you take the model view, the relationships you can create there are limited to equal joins. So if I put a filter in there, that means that the column value of this table has to match the other one. This is like writing a join in SQL, where we write one column equals the other one. In SQL, we are free to also write like where one column is greater equal than the other one, or lower equal, or not equal. This is not possible in Power BI. In Power BI, in the model view, we can only create equijoins. That's the term for that. So we can only compare an equality. But sometimes we have more complex relationships, not only in life, but also in our data models. And this is not possible in the model view. So we have to find another solution. And what I want to demonstrate here is binning, the classical thing that you have like values, but you're not interested in the detailed values so much, but you want to put, depending on the value, you want to put someone in a certain bin, like low, medium, high, or something like that, or age groups. So there's several use cases for binning. And again, I found 2 solutions so far, which I want to demonstrate and discuss here. And the one solution is that you exactly create one table with the distinct values and then group them. That means like if I know people can be like from 0 or 1 years old up to maybe 150. So if you don't have any data quality issues, 150 as the maximum number should be fine. We can also have like 200, 250, not that important. And then I create a table with values 1 to 200. And for each of the items, I write like low, medium, high, or I write like between 0 and 10 and between 11 and 20 and so on. So I just put it there. This is easy to create. And we can then use also the equijoin. So this is fast. But maybe maintaining if this is too big of a model of a table, then we get in troubles. Or if we don't have a distinct number of values for the age, somebody is either 4 years old or 5 years old or 50 years old. There's nothing in between usually. Usually we are only interested in the whole number. But maybe we need prices, and the price can be 3.49 or 3.50 or 3.51. So there's like much numbers in between, or even if we look at like floating point numbers, there's an infinite number in between. Then it's hard to build a table with all the distinct values, because either this table will be huge, or we cannot even like create a table like this, because there's always something in between. That's the one thing. And if this is the case, then we have the other solution where we create a dimension with only the ranges, and that's what we can then also use in our DAX statement. So binning is the next thing up. I would say most of the things I know your user group is the hybrid user group, so it's not so much about Power BI and not so much about analysis services, most probably, but all the principles apply also to relational databases. So what you're discussing here, it's also a good idea maybe in your relational system having a bridge table instead of having many relationships, because this can end up badly if you join table with each other and there's no clear amount of rows in the other one, then maybe your result will be wrong. Could you resolve non-equijoins by using a data vault type approach where the relationships are in a link table and all joins are equi irrespective of the actual relationship? So it's been long day. Let me think again. I try to understand the last question, because you're writing, you mean non-equi, you mean does not equal, but is not an equal join, right? So like it's a range of values. And I think this is actually my first example, right? I build a table with all possible values. and then I can link to this table with all the possible values, because I will always find a value in there. So Neil, just pay attention and then tell me if this answers your question, or if this is what you're also pointing out. So what I built here is a bin table, and as my model is so easy, again, I have only 4 rows in sales, and there's quantities 1, 3, 4, 5. So I built a bin table with a value range of 1 to 6. So now I can do an equi-join, because all of the numbers, possible numbers in my quantity, can be found in this bin table. And then, really stupid, I just write the bin just beside it. So 1 is low, 2 is low, 3 is middle, 4 is middle, 5 is high, 6 is high. And as we can see, this works. If I put then a matrix, a pivot table, so to say, here, then we can see the different products, A, B, C, and A, B, and C. And then we see low, middle, high. Then we see at A is in the middle range. Only 1 is there, and this is in the middle range. H is 3, and 3 is middle. And B has something in the low and middle range. That means B is sometimes 1, this is the low range, and then it's 4 here, so this is in the middle range. And for C, we only have 1, which is the high, 5 is high. Okay, Neil doesn't react. So this is easy to build, because I have then that's the wrong one. I have then my sales table, I have my bin table, and I can do an equity join, just joining the quantity with the quantity there. This is possible, as mentioned, if it's not too much of rows. So you can build it and you can maintain it. And if this is like a certain number of elements, and not something which can be just in a range. There could be indefinite numbers in between, like for time. This book could be really hard to build something for time, because then you have like to, if you're not really rounding, then you can go up to nanoseconds or whatever. So you could not build a table like this. But this could be easier. Like for age, I usually tend to do this. This is fast. This is easy to maintain. And you can even like build this table in Excel and tell the end users, if you want to change the ranges, make sure to change the text here, but just make sure that you don't have a low, low, middle, low, because this would be confusing. That's the only thing you have to take care, that the person who maintains this table takes care that this makes sense and is not wrong. In the case of if there's many values in between, I mean, it's the same example now to demonstrate that the same thing comes out, but maybe let's assume that we need a range table, that we need a low and a high end. So we cannot just list all the values, because there can be many values in between. And then I would build a table with 3 columns, and in this case is 3 rows, because low, middle, and high. And then I would explain low is if it's indefinitely low, whatever, and the maximum, or it should be lower than 3. If it's 3 or lower than 5, then it's middle. If it's low, if it's 5 or bigger, it's high. And I also want to point out here that it's really important, if you ask me, to have one, doesn't mean which one. There's one is inclusive and the other one is exclusive. So I can write 3 here and 3 here. And my logic is now that, like, if it's 3, it's in the middle. It's not anymore in a low section. I find this more intuitive and better to maintain, because I could also write like 2.99, but what if there's a value of 2.991? Then this would be just in between the high end here and the low end here, and I would lose the values. So that's what I try to avoid. And this is expressed in, we'll talk about the measure in a second, but this is expressed like the quantity has to be, so the low end has to be lower equal than the quantity, and the high is bigger. And so I don't miss anything. So there's no gaps, because I write it like this. So inclusive, exclusive, very important to check out here. So how is this done? So this model is very easy, because for the bin range, there's no connection, there's no filter, there's no relationship, because it cannot be. I cannot have a relationship with non-equi joins. So how did I build this? I built a measure here. So again, this is just a text box. This is not the real measure, but to make it easy for me to explain, I copy the content of the measure we're seeing here into this text box. So what do we have here? So there's sum x, there's a filter, there's another filter, and there's this count. So let's start at the outer ends. There's the sum x, and then I have this expression, which we'll talk in a second, and then I have a 1 here. So I'm summing up ones. So it's important, sum x has 2 parameters. One is a table of a list of values, a table, And the other one is an expression, and some x adds up this expression. As I have a 1 here, this means for every row the first expression returns, I count 1. So the bin count, this is this number here, counts 1 for every row I can find here. So now my challenge is to write something in here which only finds rows if this product fits into this bin, right? And what we're having here is two filters. I have one filter, I have another filter, and the first filter on the sales table. So filter again has two parameters. One is a table. The second, in this case, is a filter condition. So I have the sales and I have the bin range. So what I'm doing here is more or less having two things joined with each other, or two loops, depending on your background in IT. One or the other picture could help. So I'm iterating over the sales table, and for each row in the sales table, I'm then iterating the range table to find if this is fitting in this range. And I'm making heavy use of variables. So there's a variable, and there's a variable, and there's a variable, and then I return something here. So the first variable is the quantity. I just give the sales quantity a name and have it as a variable here. This helps me to just change the, if I want to change the measure, I just have to change it here and don't have to look in my code where to find it. It's more or less a parameter to my code. Then I have another, which is the bin. This is returning if something, or there's a list of values where my actual quantity ranges into. So I'm looking up my bin range and then checking for if there's not is blank quantity. So I'm only looking up if there is a quantity. If there's no quantity in my sales table, then I don't do anything. If there's a quantity, I want to make sure that the low end is lower equal than the quantity, and the high range from my bin table is higher than the quantity. So that's what I'm returning. So I'm returning a list of those rows for each of my sales rows. And then I'm checking if this bin has returned something, because I know these ranges are inclusive, exclusive, only maximum one row can be returned. This is what I'm checking here. So if something is returned, at least one row, can only be one row, then I'm checking if this is empty. Not is empty, so this is a Boolean, like Boolean logic. That's what I'm returning here, and this is what this is what this variable is, and this is what I'm returning. So I'm only returning something. So this is only true if I could find this quantity in my bin table. And then I get a row and I get a 1, and this is what the count then is. So any questions about the bin here and the DAX statement? We talk about modeling, but we also talk about a little about DAX statements.
We haven't got any questions about this bin.
Yeah, I see in the chat nobody is asking questions, but maybe people want to unmute themselves. Okay, so second example. Let's get further to the third example. Key value pair model. I mean, as a BI developer, BI architect, somebody working with reports, I don't like those models very much because they're awkward to query. And this is not what really is intuitive for people working with Excel or Power BI, because I need like a table with columns, and the key pair value model is only a table with two columns. I have one column with the key, which is like name, birth date, whatever, and the value, like Markus, like some date in the past. Practically, of course, there's also two more rows. So one would be the ID. So I can like, and know this is the name of this person, but the other name attribute is the name of another person, which is identifiable via the key. And most probably, hopefully, because this is what we really need. Otherwise, we are kind of in hell, because the value attribute, of course, it contains everything. It can contain a date, it can be an integer, it can be a decimal. And the only common data type to make fit for all of those is a string, a varchar, a character, whatever. So what we really also need on top of the key and the value and the ID is also a type descriptor. So I know what the content is supposed to be. So what's the real data value of this? Is this a date? Is this a decimal? Whatever. So we can convert this and can then do calculations, for example. This is sometimes really, really common for developers, because if you think you're an application developer, they must, I mean, don't say anything wrong, but like as an application developer, I'm interested in .NET and Java and whatever application. And sometimes I'm forced to store anything in a database. But as a developer, I try to have all the business logic in my program. And maybe even as a developer, I'm not so really the expert of the database and care not so much. I'm using data frameworks and so on, and I'm not complaining. But I can imagine this is it's not bad. But all the schema really presses you in something. So then you come to the conclusion you need another value in the application. Then you have to change the schema in the database. This is like awkward. With those flexible approaches like a key value pair model, we only have 2 columns. You can add something, a new attribute, just here, because you just add a new row to your table, existing table, now having also like the address, and then you fill it with the address. So this is easy for a developer perspective. And one of my clients uses this because they have like a really it's an insurance company, and you can pass in like people's, if you want to get an insurance, then you apply there and you put in all your data there. And they want to be flexible, what kind of data they gather, what kind of rules they apply, what like the outcome predictions are, and so on. So if you should like accept the customer or not. And it's really, really flexible for them. So from their point of view, cool stuff. And also if you think about JSON or like many years ago, XML, there's also flexible formats because it's the text, it has structure, but there's no need for a schema. In XML, there was like a schema, but in JSON, there is not. You can just add attributes, remove attributes. Some customers have these attributes, the others not. So this is schema-less, so to say, really flexible. It's just a nightmare if you have to build reports on that. So Kirill has to run. Yeah, see you next time. It's extremely hard to build reports on it. I mean, there's one thing which is really cool, I will just demonstrate, but usually you have to pivot the thing. So you have to put all your rows and make columns out of that. And this can be hard to do because there's a flexible schema. So what I came up here is an almost flexible thing to react to those key value pair models. So this is the third and last example I want to demonstrate here. So let's open up the key value pair model.
Whilst we're waiting for it to load, Daniel says that your comment about many years ago XML just made him feel old.
yeah, I feel that. And honestly, I never understood why the industry changed from XML to JSON. I thought like with the schema and things, and this was not so bad, but somehow things, different. There's a Q&A section as well. Okay.
Joseph was wondering about if you could explain the binning table a bit more.
Sorry? Yeah.
The values in the unconnected table for the low and high.
Okay.
So what was actually going on here?
Yeah. So this is the binning table. So this is one simple table. So if you look up, I mean, this is a table visual, but the actual table is the very same. So if I go to the bin range, then we can see here, this is a table with 3 rows, low, middle, and high. That's what I want to put in. And then here I have the ranges. So what I have here is, if it's something between 3 and 5, and 3 means inclusive. So if it's 3, then it's middle. If it's 4, it's middle. If it's 5, it's not middle anymore. 5 is then high, right? And if it's something way over the top, like 100, it's also high. And the low end, I have this differently. So if it's up to 3, not even 3, like close to 3, because 3 is exclusive, it would be in the low end. So 1, 0, 2, 2.5, if this would be a possible value, would be in the low end. Does this?
So this is an actual physical table created by you in the database to make the distinction of the values.
Yes. And this is flexible because this table could be like in the case of Power BI, this could be an Excel spreadsheet. This could be a SharePoint page, whatever. And then when we refresh Power BI, we just read the values from there. So if the users decide now we need different meaning, then somebody with the permission to change the table can just change the table, and with the next refresh, the reports will react to that. Okay. So the sort order. Yeah, very good question, because I didn't talk about that. So very good pointed out, and then I will also go back to some X and count rules, right? Not the key value pair. This is the wrong table. Come on, stop binning. Here we go. So there's also this sort order, right? This was the question here. This order helps me because, like, if I want to order after the bin and only have this as a text, then the order can be ascending or descending on the text. And L is like after M in the alphabet, right? And high is the first one. So I would have an awkward order of this. So what I put here is as a range order. This could be anything. Usually I take something like the low value and just put it here. If this is empty, I just put 1 here. But this is random things, not so random things, but it's not important if it's 1 or 100 or 1 million. The important thing is this gives the order for the texts, because if somebody wants to show the bins, usually they expect that first comes low, then comes middle, then comes high, right? We don't expect that this is in alphabetically, like with the months. Nobody expects April to be the first month. Still, it's the first alphabetically, but nobody wants to see this. And this we can do with the sort order here. And so I have the sort order column, which is part of the of this binning table. And then just here in Power BI, you can go to the bin range, the bin, and there is this option here for zoom in here, sort column by. So I can choose then for this bin column, I can choose any column to sort order. So if somebody asks for ordering after bin, indeed behind the scenes, it's not ordered by the text, but it's ordered by the sort order column. Does this answer your question? It could also have been 1, 2, 3, but this is not random that I used 1, 2, 3, because if somebody decides we need another bin, like one thing in between, like here, we need another value here, and this is 1, 2, 3, and the another one is like just between low and middle. It's like middle low. Yeah, then I would have to change also the sort order here. So I try to have a lot of gaps there to make it easy possible to insert something without the need to change the sort orders for the others. So that's why, for example, for the age groups or whatever, I like 1 to 10, I just fill 1, and for the age group 11 to 20, I fill in 11. So like the lower end, that's what I'm orienting for the sort order, just to make afterwards, if you have to insert something, easier. But theoretically, it could also be 1, 2, 3, it could also be A, B, C, anything. And then there was the other question. Oh, this answered your question, Priyanka. And then there was also the question, some X and count rows. This can be a performance thing. So obviously, when I implemented this, some X worked better. So some X of 1, of course, X results in the same thing like counting the rows. If I'm counting the rows, or I take just a value of 1 for each of the rows and summing this up, the result mathematically is the very same. But behind the scenes, Power BI or Vertipaq engine has implemented the sum and the count rows differently. And in some occasions, it can be faster having the sum X. But you're right, semantically or syntactically, you could also have used count rows in this example. So where's my mouse? I want to scroll down the Q&A. Is it the same thing in AAS? Yes, everything I explained here is the same in Asia Analysis Services. Asia Analysis Services is a tabular database, which is the very same, uses also Vertipaq, the same like Power BI. This is just different implementation of the same thing. Analysis Services is a server tool, and analysis Power BI is a client tool. And even I'm not sure if you ever did this, but this comes to a surprise sometimes. If you open up Task Manager and you take a look and you have data loaded into Power BI, so it's not working with direct query or do I have here mesh up anything here? Of course not. If I want to demonstrate this, it's never showing up. What's the thing here? Here it is. So for one of the Power BI desktop here, right? That's the budget bridge example, and then I have weird things. This is for I think this is like for the visuals to run. There's this mashup thing, which is more or less Power Query. This is the sub thing for Power Query. And then, and this sometimes comes to a surprise, there is Analysis Services. So inside of Power BI Desktop, if you're running Power BI Desktop, an instance of Analysis Services is spinned up, and this takes care of your data. No matter how big or small your data is, it's running in Analysis Services. So this, if this doesn't prove that Analysis Services is the same like Power BI, then I don't know. And it's also important for everybody working with Power BI. This is like people usually don't work so much in IT, but they also use Power BI. It might be a shock for them that when they load data to Power BI, that they're a data engineer, that they're building a data model, even if they don't care so much about the data model. So it's better to use sum X instead of count. depends. That's the true answer here. So try it out. If the count rows or count is not fast enough, one way is just to write in some x and try if the performance is better. So this is because of the complexity of how WordPack compresses the data. It's hard to predict how it will compress, and so it's also hard to predict how the performance is. So while it might work in many cases with some x is cool, maybe in other cases count or count row is better. So that's the bad answer here, unfortunately. You have to try things out. So, but now we're going to the key value pair. Or other questions regarding the previous topic, bin creation? Does it make sense to more restrictive instead of to ensure the var only returns one value rather than checking if empty or not? This is to avoid issues when someone goes ahead and makes a mistake when introducing a new subgroup later, for example. Here's the binning example. You mean this, or do you mean this one? And I also see like Kirill is pointing out that you can create a grouping and binning. Yes, you can. And I don't like it very much. So we can, for example, go there to your sales table, and then we have the quantity, and then you can create a group here. I think this is what he's referring out to. Where is it? Where is it? Collapse, hide, new group. And then you can write like, you want to have like, if the quantity is between something and something, then you have the groups in here, right? So bin size and so on and so forth. I don't like this because this is like in the data model, it's and it's like in this dialog, and if I want to change something, I have to go here again. I better like things more in the directly in the model, or like having in DAX. But yeah, this can work or not. I mean, for binning, it's okay. For text, it's really awkward if you ask me, because what do we have text? There's also this grouping here. Product description, and then we have these groups here at new group, and then we have really this group and to say A and B has done something, and you always have to go into this dialog to change it. And I think it's better to have like a table for that, which can be reside on OneDrive, on SharePoint, in a local Excel spreadsheet, somewhere in a database. Everything is better than having this in this dialog, if you ask me. So the second one, which was this one, yeah, what this is. What I need here, so like this is the table, and this is the condition. So I have to write a condition here. It's not enough to just return one or whatever. So I have to return true or false. So this has to result in a Boolean expression. This must be Boolean expression. That's why it's like written like that. So I think this is the misunderstanding between each other, right? Because if this would return one, then it will always return one, right? And one is true, it's not false, and then all of the rows would be used. So if I change this, like, let me try this out for you. So we have like the where is it? The bin count. Where's the bin count? In the bin table measures, most probably bin count. And this is the true measure. And if I just go there and return like 1 instead of the isBin, right? This is what they're suggesting, right? That we return 1 instead of isBin. If I do that, then I would expect that I get 4 or whatever the count for this product is. So only the product is not filtering. So now in every bin, no matter what bin I am, it's always like one product is sold, A is product 1 time, B is sold 2 times, and C is sold only 1 time. So I see the same thing right here. So now the filter on the range doesn't work anymore. Does this answer your question? This one. Thanks for explaining. Binning a few times. Yeah, yeah. Now go to the key value pair. Okay, let's go over there. This is the other example. So what I'm having here. So this is like this table, and this is the table like it looks like. So I get this ID. So obviously those are somehow connected. The city, first purchase name, revenue, zip, and then there's another ID with, in this case, the same amount of keys, but doesn't have to be. It could be different keys, different amounts. Maybe I have 4 and I only have a zip there. That's all the flexibility. And maybe the fourth one has, I don't know, a quantity, which I don't have in the others. This is the flexibility of this model. And that's why developers tend to like and prefer this, because this gives them independence. They don't have to deploy a database schema and all the awkward things we need in a database. What's also possible with this one is that I can put this in a matrix. So what I usually need is that I put this into a table like thing, because I want like for D1, C, city, and so on and so forth. I can do this if I use a table. So I now used this sort thing, the ID, and the key. The key is in the columns. So this is city and so on and so forth. And the value is then like in there. It demands me to like ask for first or last value, because potentially there could be that like the 3 zip and something is double in here. There could be duplicates. We never know. There's no guarantee for no duplicates in such a system. So that's why I have to provide some things like if there's duplicates, what to show, the first one. But what I cannot do here is like summing things up, because this is still text. Everything is text in here. You can see like the alignment, this left alignment, right? So 5 this is not the number of 5. This is a text of 5. But what we can do here is we can have this nice filters. So I can have the keys filtered here and also here, and then I can find out about combinations. So now I have like the city on the row, like Hofen, Seattle, and I have, for example, the revenue on the columns. So they have one with 19,000, one with 20,000, one with 5,000. I can also change this, like for example, to zip. So click zip here, remove the revenue, and then I have the different zip. So for each zip, I see a number of entries I have in my table. So this can be a powerful way of visualizing things. If you have like different combinations, the user can then decide what you want to combine and see is there cases in this zip and this city and so on and so forth. So this is really powerful. If you have a very small model, then it max theoretical public. Let's take the last question for at the end. This is about architecture premium versus analysis services. But what I usually need is like a pivoted table, so that I really have different columns, not only in my visual, but what I'm having here, I'm using the ID and so on from this pivot table. So what I took here is that I pivoted this first table and really made out different columns, a city column and so on and so forth. And those columns can have the right data type. So I now have the revenue, which is of obviously a currency, and then I can also have a sum here. And for the others, there's no sum because this is still a text or this is a date. So how can we build this? And what we always can do is either rebuild this in pivoting in SQL. That's what I actually did with the customer, where I had this model. But here I just used it in Power Query, because usually I present things in Power Query these days. And also demonstrating easier. So I don't need, for my demo, I don't need the database behind the scenes. So what we can do here, we can actually pivot things. So I can go here, like having this table with the IDs, the keys, and the values, the table we just have seen. And then I can mark this key table and over transform. And then I always have to think about pivot table, pivot column, not unpivot column. And then I have to choose the value. This is what I have the values. And in the advanced options, I want to not aggregate anything. If I do this, now the keys are transferred in the names of columns. You can do the very same in SQL. There's this pivot function or not keyword in SQL. You always have to look up the syntax. I can't remember the syntax. Here it is a little bit easier, and still I have some hard time. And afterwards, I can change the data types. So for example, I can say, okay, the revenue is not a text, but this should be like a fixed decimal. So on one hand, this pivoting is cool because it's dynamic, but on the other hand, I want to also like having this dynamically managed, because if some new attributes comes, I have to refresh this. There's no way around, but I also have to assign data types for that. The same is true if you do this in SQL. So what I did in SQL is that I used dynamic SQL to create my select statement, which does the pivoting. And before I do that, I have a dynamic SQL statement creating and changing the data, the table where I put all the data in, with also the right and converting the text into the right data types. So you can do this in dynamic SQL, and you can also do this in dynamic Power Query. So let's take a look what I did here. So the final one is that I have now also, like at the very end, you see there's a lot of steps in here. I dynamically assign the things according to, if you take a look, there's also this type in here. So depending on the type column, then this Power Query decides what type this column needs. And this could be anything. I mean, I use text in here and int64.type and date. These are the actual keywords in Power Query, but this mustn't have, I could also like have string in here or whole number in here. Just make sure that your Power Query knows what you mean with string or with text. So here I used the same keywords. So the final version is, first step is easy. So I have the source, right? This is the full table with all the 4 columns. Then I removed columns because I don't need the type in the end result. If I pivot everything, I don't need this. And then I changed the types. Not really. Yes, this got a number. And then I pivoted things. So now I get those things pivoted, but now I have the structure with the numbers. And this is what I'm now repeating. So I have this column type. Let me think. There's this column type. Okay. So this is not the pivoted thing. Independent from the steps until now, I now get a list of all my column types. So I have my keys and I have my column types. Is this big enough? So I'm not sure. I cannot zoom in. I can zoom in it, but as we're running out of time, I don't zoom in currently. If you can't read it, tell me. So I have now the keys and the types here. And then I go through, this is like, portions. So I now take care of the text column. So I now filter only to the text columns and then make a list out of that. So first it's a table and then I make a list of that. And this list I can then pass in as a parameter to a function to set all of those, what was it here? Like the column name, city, and zip, I set to text. I mean, this doesn't change anything because this was text beforehand. But for example, with the int 64, this for only the revenue is a whole number in this case. And then I get only the keys revenue. Then I make a list out of that. And then in this step, I apply the whole number to the revenue. And this is implemented now for all the things in here. So can I look on the full, not properties in here, but in here we have the advanced editor, full query code. And I was inspired and looked up, like I knew that this might be possible or not. And of course, Imke Feldman, she's the expert on Power Query. She has a blog posted about that, how to dynamically transform. And then I applied this to my key value pair and all the combinations. So this now works dynamically. And in the end, I have the right data type. So I not only pivoted it, but also assigned the right data type. So no open questions, all answered. Any question to this key value pair thing? And this is really dynamical. So if I go now to my like my source in here and add another entry, so maybe we have like, what do we want to see? Like 3, we have an address. This is like Main Street, and this is a text. And then I have like 4, have like my quantity, and this would be 4. And this is like also an int64 type. This works. So if I now run through to my final thing, so at the end I have now the quantity, the address, and they have the right data type assigned. And of course, if this is not available, it's null. If I now refresh my report, I also have this in my report now.
So we did have a key value pair question from Joseph.
Yeah.
He asks, is the key value pair approach the best practice? It seems very useful for flexible dynamic visuals, but does it have any major negatives?
Yeah, of course. Do you have to do all this work? Oh, now okay, I have some error in some of my scripts here. So because you have to do all this work, there's always a risk that like the data type does not really conform. So like here it tells you this is data type integer, but indeed there's letters in it. There's no guarantee because technically it's a string column. And just another field tells you this should be a date or something else. Also converting dates can be horrible because they can put in the date in any format. They just say it's a date, but what kind of format, and they can mix up the formats. So this is, from a data quality perspective, it's a nightmare. It's not the first thing. Why I'm demonstrating this is because one of my customers has this as a data source and we cannot change it. The application is built on a key value pair database, and then we have to do the analytics and all the reports out of that. And they just add new attributes, and we have to react to them. And so in the beginning, I just changed the model and added manually all the columns, and then it turned out this is not. I mean, I cannot do this every time. So I came up with this dynamic SQL solution where I just press a button. I could even run this as part of the ETL, but currently we don't do that. So there's some manual effort. I run my scripts, and those scripts create then automatically the tables and the views. And in analysis services in Power BI, we load the already pivoted tables. We're not doing this in Power Query. This is just for this talk that I show the Power Query solution. Yeah, you're lucky, Joseph, if you've never seen the key value approach, because like from an analytic perspective, BI reporting, this is not what we want to have. Other questions?
We don't have any more about the key value.
This is describing everything, the takeaways, take care of the model. It's really important that you apply the best practices, and it's optimized for several things, avoid the other things, and there's links and of course questions. So.
Right, great stuff. So we've got a few questions. We want to keep to time, so we won't have millions. So the first question we have is, are there any scenarios where you'd decide to push your modeling or pre-preparation modeling task to the data source database?
Yeah, of course. I mean, if you ask me, do all the preparations, all the ETL, all the quality things as early as possible. For the one reason, the earlier you do it, the easier usually it tends to be. Because if you have a database doing this is much more powerful than you doing this in Power BI on your local laptop. That's the first thing. And the second thing is, the earlier you do it, the higher the probability that the more people can use it. If I just prepare everything like here in Power Query, my Power BI desktop file, that means if I need another Power BI desktop file, another report, I have to rebuild the whole logic. So I have the logic duplicated. And another person needs the same thing, they have to duplicate it as well. So it's much better having this already in the database. So everybody who can access the database has the cleaned up and pivoted and fine data.
Varsham has a question that I think we know the answer to, and it's a 2-letter word. Sometimes people use key value because the column list is different for different records. So if there are hundreds of different distinct columns and each row only has a subset of column, will this approach perform okay?
Yeah, of course. I mean, you have this empty row, so some or many of the columns will have a lot of rows where the value is empty. For Power BI, this is easy because the Word package is really good in compressing. So if this is empty, this is just another distinct value. And this compresses really well. So if I have like a column which is empty, or it is male or it is female, if you only have binary gender, that is 3 distinct values. 3 distinct values can be stored with 2 bits, and that's what WordPack does. So this can really good compress. I wouldn't see any issue in here. So again, think of why, I mean, Power BI or analysis service, why we're building the thing. We're building it to make the users an easy job in building up the reports. And building the reports with the table only containing of strings, this is not doable because we cannot sum up strings. So the first version, to remember, the source matrix, this looks like it's a useful thing, this one. This looks like it is a useful thing. Oh, come on. So this error message here. Here we go. This looks like it looks like a table, but this is a string, and I cannot add, I cannot average, I cannot find out, cannot calculate with that because it's a string. So this is nothing what I would prefer in my reporting tool. I would prefer this one, where this is actually a number.
Cool.
So I've got a very lazy question next, and I know it's very lazy because it's me that came up with it. So can you recommend a good book for me that is going to teach me all of these modeling techniques and the DAX that goes behind it?
Yeah, so the answer is twofold, because there's a lot of books about dimensional modeling. I think the dimensional modeling rooted back to 1960 even. So this is even older than relational databases. And good books and good things to start is either Ralph Kimball, who is retired in 2015 and then announced or published his data warehouse toolkit. And so this is, read this stuff. So either Ralph Kimball or Bill Inman. And the two always had a fight. So it's really, really funny to read the text because they're always hacking to each other. So they have slightly differences, but like the basic thing is dimensional modeling is really, really important. And so you can like, this is known things for many, many years. There's a lot of books out there. The DAX portion is a different thing. This is not so tied to the dimensional modeling. But for example, if you want to an easy entrance, I would choose Matt Ellington's book, which is Supercharge Your Power BI. Matt Ellington. You can find it on Amazon, or you can buy it directly in his thing. If you want to get really in depth, there's the two guys, the Italian guys, usually referred as the two Italians, Alberto Ferrara and Marco Russo. They work with DAX since DAX was born. They were MVPs all over there, and they were really involved into the project early on. So they teach and know and write articles over DAX since 10 years or longer now, and they have a book called The Definitive Guide to DAX, which sounds like you have to be really confident to write a book like that, but they, for a reason, can be confident to write a book like this. But this is really in depth. If you want to start, I would start with Matt Ellington's book.
Great stuff, thank you.
Cool, so we have the last question. Nico asks, if you have a very small model, like 10 gigabytes of uncompressed data, would you go PBI dataset with premium per user, or would you go Azure Analysis Services?
I don't think that the size does matter so much. Of course, you have, this is a really hard question because it depends on many different things. First is that like the roadmap of Microsoft is towards Power BI. So Power BI will, or this is the vision, Power BI will be a superset of analysis services. So everything you can do in analysis services will be doable also in Power BI. In Power BI, it's much easier to do because it's much more user-friendly. It's not developer-friendly. So this can be an advantage or a disadvantage. Currently, it's the case that it's also a price thing. So if it's like really 10 gigabytes of uncompressed data, most probably this will be 1 gigabyte or much smaller. So this could even fit in a Pro. You don't need even a premium per user for that. Pro would be 10 euros, premium per user is 20 euros roundabout. So this is much cheaper, of course, than analysis services. But in analysis services, you have easier to scale the thing. So because with premium, you either buy a premium per user or you buy this premium capacity. With generation 2, it's better performant, but still you buy a certain capacity. And if it's not big enough, performance-wise, CPU-wise, memory, disk, and so on, you have to upgrade to the next level, which is double the amount, right? With analysis services, you can easily scale. So you can just buy more memory without having more CPU and the others. So there's many more t-shirt sizes, so to speak, in analysis services. So you would have to look at more dimensions to get the right answer here. Does this help? Hopefully, at least.
A good answer that states that depends.
Yeah, but this is true here.
Yeah. But I think that was the last question, wasn't it, Mark?
Yep, it looks that way. We did have a couple of comments from Daniel Zapesi, hopefully I've said that right, who these two Italian guys, he did mention their website, which is sqlbi.com/training, which is probably worth a good shout out. So thanks for that, Daniel. That's it, I believe.
Yeah, so thanks for everybody who joined us today, and a special big thanks to Markus.
My pleasure. Servus vom Österreich.
Auf Wiedersehen.
Auf Wiedersehen.